Hey everybody, welcome back to the Lennon Stand. I'm Lennon, one of our Discovery resident science explainers, and I'm here to help you do some science at home. Today we have 3 experiments, all exploring motion. First, we're going to talk about magnetic trains, talking about the conservation of momentum. Secondly, we're going to send a hot air balloon high up into the sky through convection. And lastly, we're going to try to beat air resistance and friction with a hovercraft. Now, for the very first experiment today, I have a whole bunch of balls and magnets here lined up in front of me. Now, these magnets are exceptionally strong, so much so that if I have them in the air, and I'll keep my fingers very far away, I bring them closer together, we can see as they'll snap together from quite some distance away. So these are special neodymium magnets. And what we're going to do here is we have a bunch of our very special magnets all put along in our run here with a bunch of balls in between them. And I'm going to add a ball to the very end of it, and we're going to watch what happens. So we're going to start our experiment in 3, 2, 1. So what happened then was our ball was magnetized towards our magnet as it was getting attracted towards it, and it was accelerating, getting faster and faster. And as our ball hit the magnet, all the energy that our ball gained, or all the momentum from its movement, wasn't lost when it hit the magnet. It was instead transformed and converted into momentum of the very last ball, then launching it along through our runs. Now, we won't do it again because it takes a little bit to reset this up, but feel free to take back the video so we can watch very closely exactly what happened. So this is all about conservation of momentum. This very phenomena was discovered by Sir Isaac Newton back quite some time ago, back in the days of the Black Plague, where under the effects, during the pandemic of the Black Plague, Sir Isaac Newton came up with his 3 laws of physics, while he was too in isolation like we are. Furthermore, we have a brilliant theoretical physicist, Emmy Noether, that further investigated conservation laws and realized that there is this amazing, beautiful symmetry to a lot of these different conservation laws, whether it be through momentum, or maybe when we talk about heat, we have all the energy conserved as well. So that's an amazing contribution by Emmy. So we'll put our experiment aside and keep our magnets far away from our fingers, as next we move to our second experiment, which is all about making things float by convection. So I have here just a simple tea bag that I've emptied all the tea out, and poor Gran won't be having any tea tonight because I stole them all. And I'm going to bring our lighter to the very top of our tea bag, and we're going to see as the fire burns down it, our tea bag gets lighter and lighter. We need to watch very closely to see the fire will burn out as it soars high up into the sky. This is an experiment that we can do at home alongside our parents. And now we'll stand back and watch as it gets hotter and hotter and hotter. All the hot air forcing our bag to rise high up into the sky. Now we'll do this one more time, so then you guys at home can see it very closely. Now, we'll set up our tea bag one more time, and we will set fire to it once more. And we'll see as it climbs higher, as it burns down, it gets lighter and lighter and lighter, as the hot air gathers underneath our tea bag and launches it flying up into the sky. Now, I recommend doing this experiment at home in the safety of our parents or trusted adults, so then we can see our beautiful tea bags float using convection. This is quite a safe experiment to do at home because as long as our tea bag is burnt in a controlled situation, by the time it lifts off the ground, all the fire will be gone. So there's not very much safety hazards there. Our last experiment of the day is making our very own hovercraft. And for this, we're going to need an old CD, a pop-top bottle cap, one that goes like this, and we're going to need a balloon and a hot glue gun so then we can attach it. Now, I'm going to make this in front of us so we can see exactly how it's done. Simply putting our glue all the way around the bottom of our pop-top, making sure it's nice and gluey, so then we can put it face down on our CD, and we'll hold it there for a little bit to make sure it doesn't unglue. Now we'll need to do the hot gluing with a trusted adult, because it's very hot and it may burn ourselves in contact with it. So, now that I've glued this down very well, I'm going to grab a pre-blown up balloon, very conveniently placed aside the camera, and I will now put the balloon over the top of our bottle cap, just like this, and we will see as our CD moves nearly frictionless around with the balloon dragging behind it. So we're going to do this one more time down on the ground so we can all see it very well. So I'll grab our second balloon as I'll carry it down to the ground, and our magical camera follows us along very closely. So just like again, putting the balloon over the top of our CD, and I'm pushing it along the ground. We'll push it one more time. Now we just blew out of air then. So what exactly was happening then was as the air is forced out of our balloon, the air is then pushed under our CD, creating a little cushion of air that then separates the CD from the ground, creating an almost frictionless glide to it. If we had much more air inside of our balloon, it may float a little bit. And maybe we could experiment with this at home, maybe using a larger CD, maybe like a record disc, or even a plate, and perhaps we could use a larger balloon, maybe with different gases, so we can do science to see exactly what works the best. Well, today, this ends our wonderful experiments for today. I hope we've all had a fantastic time watching some of the Lennon Stand today, and I hope we've all learnt a little bit about science and about some of our notable scientists back in the days. And I hope we're all staying very safe, and I'm going to be around for the next 30 minutes if you'd like to ask any questions. I hope to see you all next week, and I hope you enjoy the rest of your week. Thank you very much.